Chippos, man. I got this, yeah.
Derivative of e to the 2x minus 1.
2e to the 2x minus 1. Give me a challenge.
We hot. When will you niggas learn? Came to get crunk, came to bring life, came to get started, came to get right. Turn down the music, turn up my mic. The music, turn up my mic. When will you niggas learn? I mean, when I speak, I do as I say. I hustle, I grind, don't get in my way. I'm pimping my hoes, I'm jacking my foes.
Oh, sorry, I didn't see you there. So today we're going to talk about a very controversial topic, so to say. Yes, today it's all about race of races. My name is Lee Caldo. For now, it's all about math. So here we have the representatives of the races. With the white race we have Buga. With the black race we have Alex, and with the Asian race we have my brother Chong. So now let's give a little context. First, when does a graph increase or decrease? Well, it increases when the x values of a function in a certain interval are going up, and it is decreasing when the certain values in a function are going down. Yes, this is what the graph is increasing. I like to see it as a roller coaster. So in order to find where a graph at its maximum and minimum points, you have to find the first derivative of a function. Yes, and plug in certain numbers in a function to know where it is increasing or decreasing, and you will find that by seeing the signs of the result. So first of all, which of you can answer me what is the domain of this function? What is the vertical asymptote or yes? Okay, fine. We can find the vertical asymptotes with the restrictions. So the zeros will be, the restriction will be minus 1 and plus 1. X is equal to 1 and minus 1. So now in order to figure if this is a gap or a vertical asymptote, we have to plug the numbers here, and if we have number over 0, it is vertical asymptote, and if we have 0 over 0, it is a gap. 1, 0, number over 0. These both numbers are a gap, are a vertical asymptote. So now we have to look for the end behaviors of the function. That means it's going negative. What are the horizontal asymptotes? Good. Now, what is the symmetry of the function? What is the x and y intercept? Now, the symmetry, well, that is very simple. We only have to make x negative. This will turn into positive x, so that means that there is no symmetry. So now to find the x-intercept, we have to equal y to 0. So that will give us x equals to 2. The point where y is 0 would be 2, 0. Okay, so now the y-intercept. So in order to find that, we equal x to 0. Y is equal to 2, positive. Point is 0, 2. So now we have to find the horizontal asymptotes, yes? So we see that the exponent of the denominator is greater than the exponent of the numerator. Go ahead with the procedure and say limit as x approaches infinity. The horizontal asymptote is equal to 0. The first derivative.
So to get the first derivative, we're going to use the quotient rule. So this is f, this is g. So this would be this f prime g minus f g prime over g squared. Then we just solve. So we split x squared minus 1 minus 2x squared equals 4 over x minus 1 squared. Then we solve is the first derivative. So to get the second derivative, I'm going to use also the quotient rule. So this is g, this is f prime minus f, this is g prime. We use chain rule, and then we get a common factor. And x squared minus 1, I have
The x squared minus 1 by minus 2x plus 4.
minus, divide all of these terms, that is to the 1. We'll subtract 1 hour, this all with 3. Then we just multiply with this, we just add the answer.
I want you to say me the maximum minimum points, the critical points, and I want you to tell me what are the intervals, what the graph is. Black guy? Yes? Go on.
For the critical points, we're going to use the denominator. We factorize. So, the critical points are going to be when x is equal to 1 and minus 1. The maximum and minimum points, we're going to use the general equation. The maximum is going to be 2 plus square root of 3, that is more or less 3.732. The minimum is going to be 2 minus square root of 3, that is more or less 0.267. And then intervals, we know that it's going to be 1 and minus 1. So the interval is going to be minus infinity to minus 1, minus 1 to 1, and 1 to infinity. We use minus 2 to see what is going to be the sign. Just put it here. The sign is negative. This interval is going to go downwards, this one downwards, this one upwards.
I want you to say to me the intervals of the where the concavity is. What is the concavity in that interval? Yes? And the inflection points. Yes, of course. Go ahead.
So the number in these intervals minus 2. So if we put this minus 2 in the second derivative, in the x of the second derivative, gives us this sign minus. And as a conclusion for the concavity, it says that it is downwards. A plus sign, and so the graph points upwards, which is a concavity. Give us a minus sign, which states that the concavity is downwards. So here is the graph for the function given. So here we can see the vertical asymptotes, which are in minus 1 and 1. And remember that the horizontal asymptote is 0. So here we have the graph for our first derivative. The vertical asymptotes are the same, minus 1 and 1. Horizontal asymptote is equal to 0. So here is the graph for the second derivative, and it is basically the same. The vertical asymptote is minus 1 and 1. The horizontal asymptote is equal to 0.
Tell me the rate. You know what? It's too easy. I will tell you. Y is equal to minus infinity. Do not laugh. Minus infinity, comma 0, union 0, comma 0.30, union 1.8, comma infinity, and that. for our first example is f of x is equal to x. It would be f of x equals to 1, if f of x is equal to 0.